asked to calculate the area of this blue triangle, we can see this angle here is a right angle. The length of this line segment BR is 108 meters over x, while this line BP is x over 2 meters. If we look here, this angle has its size to be A, and there is also A. That is, they are congruent. The same is here. This angle and this both have their sizes to be B. That makes them congruent. So how can we solve this? How can we calculate the area of this triangle ACQ? Well, it is very simple. Starting from this triangle ABC, we can see this angle is a right angle. Here, this angle is divided into this A and this. Here also, this angle is divided into two B's. Based on the rule that the summation of angles in a triangle is 180 degrees, 90 degrees plus A plus A plus B equal to 180. A plus A is 2A, B plus B is 2B, so 90 degrees plus 2A plus 2B equal to 180 degrees. Subtract 90 degrees from both sides. Here 90 degrees minus 90 degrees is 0, while here 180 minus 90 is 90, so 2A plus 2B equal to 90 degrees. Now from 2A plus 2B, 2 is common. If we factor it out, it is 2 into bracket A plus B. Now from 2 into bracket A plus B equal to 90 degrees, divide both sides by 2. Here 2 cancels 2, while here 90 degrees divided by 2 is 45 degrees. So A plus B equal to 45 degrees. Now if you look at this angle here, say C, it is an exterior angle of this triangle ACQ. We know there is a rule that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. That is, angle C is equal to the sum of this angle A and this B. So C equal to A plus B. But from here, A plus B is 45 degrees. So C equal to 45 degrees. That is, this angle here is 45 degrees. Now if you look, this angle here and this are formed by two straight lines intersecting at this point. That is, they are vertically opposite angles. Vertically opposite angles we know are equal. So since this is 45 degrees, this must also be 45 degrees. Now if you also look at this angle, it is an exterior angle of this triangle. By the exterior angle rule, it will be equal to the sum of this angle and this. So since this is 45 degrees and there is A, that means this exterior angle is 45 degrees plus A. The same is for this angle here. It is an exterior angle of this triangle. That is, it is equal to the sum of this angle and this angle. Now look at this line segment. Its length is x over 2 meters. Let's assume the length to be y. I'll write it out here. Y equal to x over 2 meters. While this line BR has its length to be 108 meters over x. Let's assume its length also to be z. Write it out here. So z equal to 180 meters over x. Now multiply this equation by this. It will be y times z equal to x over 2 meters multiplied by 108 meters over x. This x will cancel this x, and this meters will cancel this meters. 1 over 2 times 108 is 54, while here y multiplied by z is yz. So yz equal to 54. Now let's come back to this triangle which we are asked to calculate its area. We know the formula for calculating the area of a triangle is half base times height. If we take this as the base, the height must be a perpendicular line to the base up to this vertex here. Let's assume its length to be h. So area of triangle ACQ equal to 1/2 times 26 times h. 1/2 times 26 is 13. 13 times h is 13h. So area of triangle ACQ equal to 13h. Now look at this triangle. It is a right angle triangle. SOHCAHTOA. Taking this angle as theta, there is the opposite and there is the hypotenuse, say r. So theta equal to a, opposite equal to h, and hypotenuse equal to r. From here, sin theta equal to opposite of our hypotenuse. Theta is a, opposite is h, and hypotenuse is r. So sin a equal to h over r. Now we come here, draw a line from this point which will be perpendicular to this side. Look at this triangle. It is a right angle triangle. We can use a SOHCAHTOA on it. Taking this angle as theta, there is the opposite, say m, and there is the hypotenuse. We know sin theta equal to opposite over hypotenuse. Theta is a, opposite is m, and hypotenuse is r. So sin a equal to m over r. But from here, sin a equal to h over r. Substitute here. So h over r equal to m over r. Multiply both sides by r. Here r cancels r. Here also r cancels r. So h equal to m. That is m equal to h. So this m is h. Therefore, the length of this side is h. Now look at this line here. It bisects this angle ACB of triangle ABC. That means it is an angle bisector of the triangle. Look at this line here. It also bisects this angle. That means it is also an angle bisector of the same triangle ABC. The two angle bisectors meet at this point Q. We know a triangle can have only a maximum of 3 angle bisectors, and this 3 angle bisectors meet at a particular point called an incenter. So since this angle bisector and this meet at this point Q, that means point Q is the incenter of triangle ABC. Since point Q is the incenter of the triangle, if we draw a line from this vertex which will pass through the incenter, it will also be an angle bisector. That is, this angle is bisected. The angle is a right angle which is 90 degrees. So since it is bisected, this and this part each will be half 90 degrees, which is 45 degrees. Now look at this triangle. It is a right angle triangle, and we have the size of this angle to be 45 degrees. Based on the rule that the sum of angles in a triangle is 180 degrees, this angle will be 180 minus 90 minus 45 degrees, which is 45 degrees. The fact that this angle and this angle are congruent tells that the triangle is an isosceles right angle triangle. We know the perpendicular sides are congruent, that is, this side and this. So since this is h, this must also be h. Now from this triangle, if we use the Pythagorean theorem, which states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides, where the hypotenuse is the side facing the right angle, which is this side here, let's say n. So by Pythagoras, n equal to h squared plus h squared. H squared plus h squared is 2h squared. So n squared equal to 2h squared. Take the square root of both sides. Here square root of n squared is n, while here square root of 2h squared is h root 2. So n equal to h root 2. That is, the length of this side is h root 2. Now look at this triangle. We have the sides of this angle to be 45 degrees, and this is 45 degrees plus a. Based on the rule that the summation of angles in a triangle is 180 degrees, this must be 180 degrees minus 45 degrees minus 45 degrees plus a. Minus 45 degrees plus a is minus 45 degrees minus a. Minus 45 degrees minus 45 degrees is minus 90 degrees. 180 degrees minus 90 degrees is 90 degrees. So it is 90 degrees minus a. By here, a plus b equal to 45 degrees. Subtract b from both sides. Here b minus b is 0. So a equal to 45 degrees minus b. If we replace this a with 45 degrees minus b, the angle is 90 degrees minus into bracket 45 degrees minus b. Minus into bracket 45 degrees minus b is minus 45 degrees minus minus b. Minus minus b is plus b. 90 degrees minus 45 degrees is 45 degrees. So it is 45 degrees plus b. This can be written as a. And let's compare this triangle and this triangle. Both have an angle 45 degrees, which are this and this. And both also have an angle b plus. That is this and this. This proves that the two triangles are similar. So since this is a plus 45 degrees, this must also be a plus 45 degrees. Now if you take the ratio of their sides, this side facing angle a plus 45 degrees divided by this side also facing angle a plus 45 degrees must be equal to this side facing angle b plus 45 degrees divided by this side also facing angle b plus 45 degrees. So h root 2 over z equal to y over h root 2. Cross multiply. So h root 2 times h root 2 equal to z times y. H root 2 times h root 2 is h times root 2 times root 2. H times h is h squared. Root 2 times root 2 is 2. H squared times 2 is 2h squared. Here z times y is yz. So 2h squared equal to yz. We have here yz equal to 54. Substitute it here. Now 2h squared equal to 54. Divide both sides by 2. Here 2 cancels 2. While here 54 divided by 2 is 27. So h squared equal to 27. Take the square root of both sides. Here square root of h squared is h. While here square root of 27, we know 27 is 9 times 3. And square root of 9 times 3 is root 9 times root 3. Root 9 is 3. 3 times root 3 is 3 root 3. So h equal to 3 root 3. Substitute it here. Now area of triangle ACQ equal to 13 times 3 root 3, which is 39 root 3. So area of triangle ACQ, which is the blue area we are asked to calculate, is 39 root 3 square unit. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications.